So in this video I want to go through some more examples of adding and subtracting with algebra and collecting like terms. So in each of these examples we have two variables, two different letters that we're working with. So let's look at our first one. So we've got A plus B. Now remember, you can't combine together two terms that are of different form, shall we say. So they are unlike terms. So A and B cannot be combined, but the two A's here can. So we have A plus A, which of course is 2A, and we've got the B on the end. And that's as neat and as simplified as I can make this. Okay, so we can combine those two bits, but that bit has to stay on the end. How about with number 2 then? We have 2x plus 5y take away y. So these two terms can be combined because they're both in terms of y, but this is in terms of x. So this one I cannot combine with these, and that has to stay by itself. So the 2x remains as it is. But 5y take away y, well, that's 4y. So I'll have the 2x plus the 4y. And that's as neat as I can get it, as simplified as I can get it. Number 3, we have 3w take away 5w plus z plus 8z. So the w's can be combined and the z's can be combined independently, but they cannot mix. So the 3w take away 5w, well, if I've got 3 take away 5, that's minus 2. So we've got minus 2w. And then we have z plus 8z, which is positive 9z, so plus 9z. Okay, so I have collected like terms together. I've collected the w's together, I've collected the z's together. Right, how about for number 4 then? We have 6p plus 3q plus 10p plus q. Now this time I've mixed the terms up, but that shouldn't worry us. We should focus on collecting the p's together and collecting the q's together separately. So let's first collect the p's together. 6p plus 10p is 16p. And then I've got 3q plus a q, so 4q. Now you might be thinking, well, do I have to write these in a specific order? Do they have to be in alphabetical order? Well, generally no. Alphabetical order is probably, in the majority of cases, what we aim for. But this one, for example, if we go back to number 3, minus 2w plus 9z, there was no reason as to why we couldn't have collected the z's together first and got 9z, and then had take away 2w. Okay, because adding minus 2w is the same as just subtracting 2w. So these two things mean the same. Okay, and either answer would have been perfectly fine. Right, number 5, we have 5c take away d take away c plus 9d. Now sometimes although I've mixed the terms up again, so I've got CD, CD, having the negatives in there sometimes causes confusion. But still think of it as, well, I've got 5c, and remember you're working from left to right, so 5c take away c. So the 5c and the take away c can be collected. 5c take away c is of course 4c. And then I've got minus d plus 9d. So you can kind of think of this as, we can kind of forget the d's are there at first, and then we can forget the c's are there. So minus d plus 9d is 8d. And so they're combined. Now how about the last one? 16n take away 5m take away 3m take away 20n. So again, I've muddled them up, and you might be going, well, let's deal with the m's first because I want them in alphabetical order. That's perfectly fine, we could do that. Let's deal with the m's first then. We've got minus 5m, take away 3m. Minus 8m. Minus 5 take away 3, it's minus 8. So minus 8m. We then have the 16n, take away the 20n. So 16n take away 20n, 16 take away 20 is minus 4, so minus 4n. And as I was saying up here, if you dealt with the n's first, then the m's, minus 4n take away 8m is a perfectly fine answer here. Okay, it doesn't matter which way round we have it. So, hopefully you're starting to kind of build up your confidence with how we can collect like terms together.